we're going to use this web application that I built to load charts and tables into two state-of-the-art vision models and ask questions about the content in our tables and charts. The two state-of-the-art models, vision models, are GPT4 Vision and Gemini Pro. And it's based on all the work that I do. These two guys are the state-of-the-art vision models right now. And here's the rough agenda for what I want to do in the video today. First, we're going to load a single PDF page document, convert that to a JPEG format, feed that into a large vision model, and ask a question about the chart or table in that PDF slide. Second, I want to do something similar, but with a multi-page PDF file. So we'll load a multi-page PDF file, convert each slide in that PDF to a JPEG image, and then feed all of them into a large vision model. The reason for using a JPEG format is basically converting a PDF document into an image, a picture. These models, they require the input to be a picture, an image. So your limitations are it limits you to JPEG or PNG, pretty much those two formats. And then third, what I want to do is repeat number 2, but instead of feeding all the pages, all the images into the model, we're going to use embeddings. And the motivation for doing that is a couple of reasons. It is two key reasons. The first one is it can start to add up in terms of dollars. So when we load, let's say I have a 10-page document and I load those 10 images into GPT-4 Vision, GPT will charge me for each one of those images. Now 10 images is not going to break the bank, but in reality, a lot of times we're dealing with 100, 200-page documents. It will add up, trust me. The second reason is the size. The size of the file is a limitation for GPT-4, and for Gemini, currently we can only load 16 images at a time. So there's there you go. There's motivation for why you might want to use embeddings, and I'll unpack a little bit about what that means when we get to it. And finally, something towards the end of the video I'm going to show you 2 really cool use cases that these large vision models are darn good with compared to reading charts and tables. So let's get going. But before I do that, I have an ask. Please like my video and subscribe to the channel if you haven't done that already. And everything that I'm showing you here and everything I'll show you in the remainder of the video, I will leave a link in the description below, including the code that I wrote that built this web application. It's yours. There will be a link to it in the description below. So let's get going. Here's the 2 documents. Let me quickly show you. The first one is a slide I clipped from PNC Bank's first quarter 2023 earnings report. It's publicly available. And second document is also from PNC's first quarter 2023 earnings report, where I clipped 5 consecutive slides instead of 1. So let's get going with that 1 slide document. And we'll just start with GPT-4. And so let's take a quick look here. What I want to demonstrate to you is that these vision models are good at taking this image. So it's going to get this as a picture, and they're good at reasoning. Not perfect, but much better than the models that were available just about 6 months ago. So let's see. I'm going to ask, what was the loan yield in 1Q23? The answer is 5.29. Well, I'm looking to see if these models can reason. And what do I mean by that? It's going to have to come to this, look at this picture and say, where is the loan yield? It's on this side, so it's got to be this little graph here. And then, hey, loan yield is, the legend tells me the loan yield is designated by this little circle. And 1Q23, I got to read these different labels to figure out this is 1Q23. Look for this circle, and that's where my answer is. So let's see if that's what will happen. What was the loan yield in 1Q23? Answer is 5.29. Let's see if that happens. Yep, it tells you it got it from this section. Correct. Answer is right. Let's go to Gemini. So this models, especially these two models, are so much better than things that were available to us, even 6 months ago. 5.29. Got it. Let's try the other document that has multiple pages. The reason I want to do that is that in this case, it's going to require another layer of reasoning because there are 5 pages. So it's going to have to take our question and figure out which of these 5 images, because each one of these pages will get converted to an image, which of these images has the answer, then come to that page and figure out what is the answer and bring that back. So since there are 5, I'm going to make it go to like the middle one. So this will be the middle. It has to come here to find the answer. What do I want to ask? Let's ask net income. What was the net income for the same? We'll stick with the same quarter, 1Q23. Let's quickly see what the answer is. 1.694 billion. Yeah, Gemini is Gemini compared to GPT will be more concise and precise. 1694, it just rounded that up and said it's 1.7 billion. That's correct. GPT is a little bit more verbose, but it's okay. Sometimes it's actually helpful, and at times it's annoying as well. 1 point, no, it's not right. We know it's 1694. Did it say where it got it from? It got it from a slide called Income Statement Performance. Income statement. Yes, it came to the right slide. 1429. Here is 1429. Here's what happened. So both of the models got to the right slide. They both got to the right row. Figured out net income is in this row. GPT4 went to the wrong column. Google went to the right column. Okay. Hey, not perfect, I said, but darn good. Trust me, compared to even just 6 months ago. We want to stick with the same document now, but we want to use embeddings. So we'll just switch over to embeddings. It's going to use the same document, same question. This will take a little while. Let me show you what we're doing here. We have to create embeddings. So luckily from LangChain, open source, there's this implementation called OpenClip, which allows you to do multimodal embeddings. So you can create embeddings for images or text using OpenClip implementation from OpenAI. And when using OpenClip, we have to point to which embedding model we want to use. We're using this guy because per LangChain, this is one of the better performers. So that's what I used. This might still be running. It's okay. But with embedding, so that here's what's happening. Instead of feeding, in this case, each of those 5 images, I'm saying, hey, create embeddings for each of those 5 images. Then take the user's question, in this case, is what was the net income for 1Q23, and see which of these 5 images possibly has my answer. And I think the default is to take only 2 of the 5 and feed it into the model. So instead of sending all 5, you're only sending 2. And yes, you can limit how many you want to send. You can say 1. You got to send 1, and you can send then as many as you want. So that's why sometimes it might be better to use embeddings when you have a, let's say, 500-page document. Or let's be realistic. Let's say 100-page document, and you don't want to feed all 100. Maybe you want to feed the top 5 that most likely has the answer, and that's where embeddings are helpful. All right, this is a very long answer, and I do not see 1694 anywhere on here. So, hey, wanted to show you how you can do this in different ways of doing it, right? So you did not get it right, but hopefully through my code, you will be able to use embeddings. This was just 5 images, but trust me, embeddings are helpful when you have very large documents. The next thing I want to do was those 2 use cases that I know you guys will like, and hopefully inspires you to think of other use cases, and then use my web app, my code, to build your own web app and try out your use cases. So first use case for me was like, hey, let me come up with a sketch. So I drew this and I saved it as a PDF. I sketched my idea, which is I want to build a stock price app, the header stock price app. I want to give the user the option to select a stock symbol, by clicking on this drop down and then provide a date range, and then I want to plot the stock price for this date range for that stock symbol they selected. That's what I want to do. By giving this image, I want to get a code, a Python code in return that would build that app for me. Okay, so let's start with vision here, and before I do anything, let me make sure this is an option, tokens, because this especially GPT-4 can be very verbose. I don't want to spend any more money than I need to, so I limit tokens and how many word answer do I want back. But this code could be somewhat longer, so I need a Python code that will build a web application using Streamlit based on the image provided. Let's say that based on I'm not a master prompt engineer here, but good enough. Okay. These models are typically good with this. I hopefully 500 tokens is long enough for it to write a code. Honestly, I've done things like this. That sketch that I showed you, total of like 3 lines for imports, two lines for import. Like in 7 lines, I could write that code that would build that app. GPT is pretty verbose. So here's the code. It starts here. Okay. Well, yes, this is one way to do it. Have this 4 different libraries you would need. It gives you the stock price app. It even explains it. Okay, I like that. And then, okay, instead of giving a whole lot of stock symbols, it said, hey, out of this 5 stock symbols, pick one. Okay, start date, end date. Okay, this is wrong. I never set it to start with today and do -30. I wanted, okay, so this is not what I wanted, but it does come up with a start date and end date. Okay, let's just do this. It's writing a really big code, and it shouldn't. I can write this code in 7 lines, 8 lines. Brother, okay. I changed the number of tokens because it's got cut off here, so I can't judge whether it got the whole thing correct or not. Okay. Data load Saint line chart. Close. Run the Streamlit app. Okay. So I don't like what it did here. That's not what I wanted. This is too fancy, but it would come back and give you this, but not exactly what I had in mind. But okay, that's fine. This is, I think, very helpful for people who are, I would say, moderately good with Python coding, right? You got to be somewhat proficient with it, because otherwise you will not know that it's the wrong code, and you run it and you're like, that's not what I asked for. So those of you who code, quite a bit, and this is a good starter. It gives you a head start. Even if 1/3 of it is wrong, you got a head start on 2/3 of the code, right? So that's how I look at it. Much more precise or concise with Gemini. Okay, start date, end date. It actually just put something in there. So again, it's right. It's up to interpretation. Select. I didn't say let the user, right? I never said select time frame. Let the user select time frame from date to date, right? So I didn't say that. So it said okay. Okay, so it's up to interpretation. So I won't penalize it. So it's just putting in 2 dates. Okay, same thing with GPT-4. Maybe I'm not going to penalize it. They just put in dates for me. It's going to download the stock symbols. Oh yeah, okay. This guy also limits it to 4. That's fine. Out of the 4, pick one. And for this date range, it's going to plot the stock price. Yeah, this will do it. Although technically, if you're going to use PD, it forgot to import one library. So again, 95% of the work was done for you to create this. So I like it. All right, the second one. Here, some calculus here, right? Pretty straightforward for those of you who know calculus, right? The answer is 2 times 3, 6, 6x plus 0. Okay, so you can do things like this. This is, for me, pretty straightforward calculus problem. I've done some like really, really hard things that I have wrote out, say solve this, and it does a good job with with calculus. So I wanted to showcase to you that I wrote this down, my handwriting. I wrote this equation, and I'm going to feed this and say solve this. Okay. So let's upload the image first, or the PDF. It's going to convert that into an image. Solve the equation in the image step by step. The derivative of 3x squared plus 3 with respect to x. So that's all. We're trying to take the derivative of this function with respect to x. The answer is 6x. I already told you that. GPT4 revision. I can guarantee you it will be more verbose. It always is. I mean, this is, again, it comes down to, I mean, I could have come back and said, explain in as many steps, step by step. Prompting does matter. GPT-4 is a little bit more verbose, and it's actually walking you through the different steps. Differentiate this with respect to x, which simplifies to 6x. The constant becomes a 0. Answer is 6x. All right. Hey, there you go, guys. We tried a few ways to use the vision models, the 2 state-of-the-art models today. One on charts and tables, where these 2 state-of-the-art models are much better than something, 6, 7, 8 months ago that we had. So it's getting better and better. Not perfect, but it's much better with things like this, right? Like if you had handwritten things like this, especially, somebody who's in college or, in graduate programs and trying to solve problems. I mean, just write it down, upload the image, it gives you the answer. You can do that, but please make sure you understand why the answer is what it is, right? And then with things like this, it's good too, right? In our case, I think OpenAI got it maybe 70% of the way there. Gemini got us to almost 95% of the way there to building this app. So hope you enjoyed it and found it helpful. I have the code, the link to the code, link to everything else that I was showing you. Until next time.